All right, we are to Chapter 7, Lesson 4, Systems of Equations. Now let's talk about what a system of equation is. What it says is that a system of equations is a set of two or more equations that contain two or more variables. So is a set of two or more equations that contain two or more variables. So the first system of equation that we're going to be looking at today is going to be this one. Y equals 4x minus 6 and y equals x plus 3. Now let's see if this fits this definition. It's a set of two or more equations. Well, this is equation number 1, and this is equation number 2. So yes, okay, there's two or more equations. And that contain two or more variables. So here we have an x or y, so x and y, so that's two variables, and here also. So that's what it means. This is a system of equations. A lot of times with the system of equations, they'll use this, but I think they use that more in algebra. I don't know if I saw it in your textbook. I can't remember or not. But a system of equation is a set of two or more equations that contain two or more variables. So let's talk about the next part. It says a solution. Remember, a solution is like the answer. The solution to this systems of equation, so a solution of the systems of equation is a set of values that are solutions to all the equations. So it's a set of values, the solutions that are to all the equations. That means you have to have a solution to this one and also a solution to this, to both. And it says, lastly, if the system has two variables, which this does, the solution can be written as an ordered pair. Now, what's an ordered pair? An ordered pair is something that has an x and a y. So just one example of some random ordered pair could be something like -2, 1. It's talking about coordinates on a graph. Now, that's weird. It's saying that the solution to this is actually an ordered pair. Now, let's go into this because we are going to solve this using our wonderful algebra skills that we've been working on. But what I want to do is I want you to understand what's going on here. And to do that, what we're going to do is we're going to actually start talking about Chapter 8. The biggest thing that you need to know is you're not going to be required to do this at this time, but I just want you to understand the big picture of what's going on. So we have this, y equals 4x minus 6 and y equals x plus 3. This just looks like an algebraic equation, and so does this. But what this is, every single algebraic equation that you have, it represents a picture. So this is a picture, and this is a picture. And every single time you have a y and an x, and notice this x is just a normal x. There's nothing in the exponent. Actually, there's a 1, but you don't write 1. But it's not x squared, it's not x cubed, it's not the square root of x. It's just a regular old x. So anytime you have a regular y like this and a regular x, the picture of this is always going to be a straight line. Okay, and then this is, this equation, we have a regular y and a regular x again. So whenever you have a regular y and a regular x, it's going to be some other type of straight line. And so the solution to both of these straight lines is where those straight lines intersect. That is the solution. That is why it's written as an ordered pair, because it is an ordered pair. Okay, let's go ahead and actually talk about this first equation right here. And you're not going to be expected to do this at this point, but I really want you to understand what's going on. So this same equation, whenever it's written in this format where it's solved for y, what you know is you know some things. I know that there's a number touching the x, and I know that there's a number out here on the side. We call it what, the third party? Okay, this happens to be called a specific name. This is the y-intercept. That is where this line intercepts the y-axis here. So it intercepts at -6. So -1, -2, -3, -4, -5, -6. That's right there. That is the y-intercept. Now, from the y-intercept, there is the slope. This is the slope. It is called, I'm going to put it up here. This is the slope. The slope has to be converted to a fraction, which is 4/1, and you'll learn about this. But the slope is the rise over the run. So this means it rises at 4 and it runs 1 from this intercept. So from this y-intercept, I'm going to make this y-intercept yellow. This is the y-intercept is a -6, and there's our little point there. From that y-intercept, we are going to do the slope, which we're going to rise up 4 and go over 1. So from this point, 1, 2, 3, 4, up 4, over 1. There we go. And I could do it again. So that's my first slope right there. And then I can keep going from there. Up 4, 1, 2, 3, 4. Wait, 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. And what I have now is I have a straight line. This is the picture of this equation right here. That is what this looks like. This equation looks like that line right there. Okay? Now we are going to do the same thing for this equation. Okay? So this is the number on the outside. It is the y-intercept. The y-intercept is a +3. So we're going to go up 3. 1, 2, 3. Right there. Okay? And then there is no number, but actually there is. Right next to this x is a 1, and we make that 1 a fraction, so it's 1/1. This is the slope, which means you rise up 1 and you go over 1. So from this point, you go up 1/1. That's the slope from this +3 y-intercept. Then you go up 1/1, and then up 1/1, and then up 1/1, and then you keep going up 1/1, up 1/1, up 1/1. So this is what this picture looks like. It looks like that. So this equation right here is represented by this purple line. Now, so this is a systems of equations. This represents two pictures of lines, and the solution to this is where these lines intersect. That is the solution right there. And if we look, we can see that the solution is, what is it? It's 1, 2, 3. So the x part is going to be 3, 1, 2, 3, 4, 5, 6. Whoa. So 3, 6. That is the solution. The x part is 3 and the y part is 6. Okay, so now that we have solved this graphically, you're not going to have to do this. This is just, well, not yet at least. This is just for your just understanding big picture of what's going on. We've already figured out that the solution is where these two lines intersect, is 3, 6. Now, what we're going to do in your notes is we're going to figure this out algebraically. So, to do this algebraically, what I know is I know that y is equal to 4x minus 6, right? And I also know that y is equal to x plus 3. Now, since 4x minus 6 is equal to y and x plus 3 is equal to y, they are actually both equal to y. That means they're both equal to the same thing. So what we can do is we can set these equations equal to each other because they're both equal to the same thing. So if they're equal to the same thing, that means they're equal to each other. So we can write this, 4x minus 6 equals x plus 3. Now we're just to our solving equations with variables on different sides, but we can totally do this. We need to get the variables on the same side, move the smaller. We have 4x and x. It would be subtracting x to both sides. 4x minus x would be 3x minus 6 equals 3. From here, we just need to isolate x, right? So we're going to have to do the inverse of a negative 6, which would be a positive 6 to both sides. That cancels. We're left with 3x equals 9. And so we got to isolate x. It's 3 is related through multiplication. The inverse operation would be division. 3 divided by 3 is 1. 1 times x is just x. So we get 9 divided by 3, which is 3, which means x is equal to 3. Now, this is why it's so important that we understand what we're doing, because it's very, very easy to be like, oh, we did this, we got an answer, we're done, but we have to know what we're doing. This is a line, this is a line. The solution to this is to find where those points intersect. And if you see x is equal to 3, that's what we found, but we have to find the ordered pair, which means we also have to find this y value. So, in order to do that, all we need to do is take one of these equations. It really doesn't matter which one. I'm going to take the bottom one because it's, easier. And write the original equation. And then what I'm going to do is substitute x equals 3 in for this x because I need to figure out what y is. Because I'm trying to find an ordered pair. I know that my x, an ordered pair, has an x and a y, right? I know that my x is 3, but I have no idea what my y is. I need that for the solution to these types of problems. So to do that, I'm going to pick equation, put 3 in for x, so I get y equals 3 plus 3, and that means that I get y equals 6. And that's what my ordered pair is. That's my solution. My x is equal to 3, and my y is equal to 6. So 3, 6, and if you look here on the graph, that's exactly what we came up with here, 3, 6. So the last thing that you're going to have to do is you're going to have to check your answers by hand. And since there's 2 equations, you're going to have to check both of them. So first, let's write the first one, y equals 4x minus 6. And here is our solution, x is 3 and y is 6. You put a 6 in for the y, and you put a 3 in for the x. 4 times 3 is 12 minus 6, and yes, this is a true statement. 12 minus 6 is 6. This is a true. What does that mean? Well, this means that this point is a solution to this equation. This means that the point, it's always important to know what this means. The point that we stuck in, which was 3, 6, is a solution to the equation y equals 4x minus 6. Okay? Now, what that means graphically is that, remember, this is our equation right here. Which one did we do first? Yeah, the 4x. It's this one. A solution to this means that it's a point on the line. So 3, 6 is a point on the equation, the line y equals 4x minus 6. It's that point on the line. That's what we just found. Okay, so let's do the check on the other one. Okay, so we're going to write the original equation, y equals x plus 3. Stick in our 6 for y, stick in our 3 for x, and we get 6 equals 6, which means that the point we stuck in, this is also true, it means the point that we stuck in, the point 3, 6, is a solution. It means it's a point on the line. It's a solution to the equation y equals x plus 3. And it's very, very important to know that since we have 3, 6 is a point on this line, and it's also a point on this line, that is the point where they intersect. So that's what you're doing, which means, again, it's the solution. That's what you're doing when you're doing this check. You know, sometimes it's easy to just jump through the hoops and, oh, I'm doing a check. But it's more important to understand what you're doing. When you find this true statement, it means that 3, 6 is a point on this picture, which represents a line. And this 3, 6 is a point on this picture that represents on a line. And since they're both points on these two different lines, that must mean that that is the point of intersection, which is the solution to this type of equation. Okay. So let's move on and let's do the second problem. We're going to move to example 1b. We're going to solve this systems of equations. So here again, what I see, there's a regular y, regular x, regular y, regular x. So that means that we have another picture of a line. So this is going to be some picture of a line, and this is going to be some picture of a line. And what we're trying to determine is where they intersect, okay? Which would be a point, x, y. So we need an x and we need a y. Okay. Now, let's go ahead and, okay, yes. Okay, we know that this is y, right? This is y. And we know that y is equal to 2x plus 9. We also know that this is y. And this same y is also equal to negative 8 plus 2x. Since they are both equal to the same thing, this is equal to y and this is equal to y, what we can do is we can set them equal to each other because they're both equal to the same thing. So we have 2x plus 9 equals negative 8 plus 2x. Okay, so we're just going to go ahead and solve this. Okay, I'm going to move the smaller, but oh my goodness, I noticed that this is 2x and this is 2x. So there's not one smaller, so I'm just going to move one. I'm going to move this negative 2x to this side, and look what happens. 2x minus 2x cancel, 2x minus 2x cancel. Ah! What does this mean? What does this mean? The x's canceled out, the variables canceled out. Is this okay? Yes, it is okay. Okay, we have 9 equals negative 8. I know it feels really, really wrong, but it is totally okay. So the x's canceled out. This means two things. Remember? It means two things. So when the variables cancel out, it means two things. It means if you have a, remember, a false statement, it means no solution, right? And if you have a true statement, it means infinite solutions. So let's look and see what we have here. We have 9 equals negative 8. All right, so is that a true statement? No, it is a false statement. Those are not equal, okay? Which means that the answer is no solutions. Okay, no solution. So let's go ahead. We talked about this being a picture of a line, and we talked about this being a picture of a line. Let's see why are these two equations no solution? Because I thought what we were doing is we were figuring out that this line and where they meet, that's the solution. It has an x and a y. Now, let's go ahead and take a look at what's going on with this particular equation. So the equations are right here. And to do that, let's go ahead and graph it. You're not going to have to do this for your homework, but I want you to understand what's going on. So here, the number, we have y equals 2x plus 9. You need to be able to know that the number touching the x, that's going to be the slope, and the number on the outside, the third party, that's the y-intercept. So we have our y-intercept equaling 9, and then our slope is right here. And you always have to change the slope to a fraction. Okay, so let's graph our y-intercept, positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And then our slope from there is going to go up to 1, 2 over 1, right there. Now, the crazy thing about slopes is you can go up to, so 1, 2 over 1, or you can do the opposite, but you have to do the opposite in both directions. So I can go down to 1, 2 over 1 this way, down 2 over 1 this way, down 2 over 1 this way. So let's down 2 over 1 this way, 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 down 2 over 1 this way. There we go. Now, let's talk about why we can do that. So the slope I have for this equation is m equals 2 over 1. And what I'm saying, so that's a positive 2, positive 1, 2, and a positive 1. What I'm saying, this is the same as going down 2, which would be a negative 2, and going negative 1. And so I was going from here, I was going down 2, and I was going in the negative direction, negative 1. So that's what I was doing, and I was saying, hey, these are the same things, and is it the same thing? Well, yeah, because a negative 2 divided by a negative 1, a negative divided by a negative just ends up being a positive, so it actually is the same thing as 2 over 1. All right, so I'm going to connect these dots here. And that is what this line looks like right here. That is the equation to that line. All right, now let's do this one, y equals negative 8 plus 2x. Now this one is kind of like the order is kind of swapped, but I just need to be able to find the x. If I can find the x, I'm good. So here's the x, the number right next to the x, that is the slope. Okay, so even though they're just the order swapped, it's totally okay. And the slope is still going to be 2 over 1. And so since this is where the slope is, this number on the outside is the y-intercept. So here, the y-intercept is negative 8. So I'm going to go ahead and I'm going to graph that. So negative 8. So this would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8 right there. Now from this point, I'm going to graph the slope, which is the rise over the run. So you're doing the y value and then the x value. So up 2, 1, 2 over 1. 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 Up 2 over 1. Up 2 over 1. And then I could do the opposite. I could go down 2 over 1 this way. And I have this equation. And see what that looks. Now, what does that look like? These are actually parallel lines. And the cool thing about parallel lines is they always have the same slope. So when you look at this equation, just by looking at it, the slope is here, right? This equation, the slope is 2. And up here, the slope in this equation is 2. So since the slopes are the same, the cool thing about that is once you get used to working with these lines, you can just look at these two equations and you can say, hey, the slope is 2 here. Hey, the slope is 2 here. I'm going to have parallel lines, which mean parallel lines always mean that there is no solution. Well, why is there no solution with parallel lines? If you're remembering, when we were doing this problem, we were looking, a solution is where the lines intersect. It's that point of intersection. Well, there's no solution because the lines never intersect. There is no point for intersection, so that's why that there is no solution. All right? So, like I said, this is not what you're required to do. You are, however, required to do this bit right here with the algebra, but like I said, I'm trying to get you guys to understand that no solutions means that these two lines are just pictures of parallel lines. That's what's going on. We have two parallel lines right here. And you might be asking, okay, well, no solutions means that you have parallel lines, which means the lines have the same slope. Well, somebody might be asking, well, what happens if we have a statement that's true and there's infinite solutions? Well, what does that mean? Well, what that means is that, I'm going to use a highlighter because it's fun. That means that you have a line like this. And then what you have, I'm going to use yellow, is you have another line right on top of that same line. You have two lines directly on top of each other, which means that they have not only the same slope, but they also have the same y-intercept. So that's what it means when you have infinite solutions. There's infinite solutions because there's infinite amount of points that they both have in common because they're practically the same line, even though they're two different lines. They're two different lines, which is the same line on top of each other. So they have an infinite amount of solutions because they have an infinite amount of points in common. All right? So now it is your turn to go ahead and check it out. So it is time for our lovely friend, the Pause Dragon, to come along and remind you that you need to pause this, go ahead and work out example 1A and also example 1B, and then we will see you in a little bit. Good luck, you can do it. All right, so we are back and we are going to solve this systems of equations. All right, so what I see that this is equal to y, and y is equal to x minus 5. And I also see that this second equation is equal to y. But it's y is now equal to 2x minus 8. Well, since the top equation is equal to y and the bottom equation is both equal to y, that means they're equal to the same thing, which means we can say that they are equal to each other. So we're just going to set these equations equal to each other. And just solve. So we got to get the variables on the same side. We're going to move the smaller one, which should be to move this x. We get negative 5 equals x minus 8. And just need to isolate the x. So we're going to get rid of this negative 8 by doing the inverse operation, which would be adding a positive 8 to both sides. That cancels. We're left with negative 5 plus 8, which is a positive 3x, some symmetric property of equality. I'm going to have it be x equals 3. Now, are we done? Well, we have to remember what we're doing. This is a picture of a line. This is a picture of a line. We are looking for the point of intersection, which is an ordered pair or a point. It has an x and a y. So far, we have found the x part of this point. We know that the x is 3, but we need to figure out what the y part is. We don't know that. But it's super easy to figure it out. You just pick one of the equations. I think the equation on the top looks a little easier, so I'm going to pick that one. I'm going to write the original equation and then stick in 3 for x. Y equals 3 minus 5, which means that y equals negative 2. Well, that is our x part, our y part, I'm sorry, negative 2. So we have our point of intersection. Now what we're going to do is we're going to go ahead and check our answer and make sure that it's right. To do that, we're going to write the original equation, y equals x minus 5, and plug in this point. So our x is 3, our y is negative 2. So instead of writing y, I'm going to write negative 2 equals, instead of writing x, I'm going to write 3 minus 5. I'm just going to do the math. Can't do anything here, so this is negative 2. 3 minus 5 is negative 2. This is a true statement, which means at this point, the point 3 negative 2 is the solution to the equation y equals x minus 5, which means on a graph, this point is on this line. That point is on this line. That's what that means. Okay, so we did that. Let's do the second check. Y equals 2x minus 8. Okay, this is our x, this is our y. We're going to stick in negative 2 for y, and our x is 3. We're just going to do the math. We get 6 minus 8. Is this equal? I don't know. 6 minus 8 is negative 2, so this is a true statement as well, which means the point 3 negative 2 is the solution to the equation y equals 2x minus 8, which means this point is also on that line. If it's a solution, it means the point is on the line. All right, let's go ahead and let's go graph this. This is not what you're going to have to do, but I just want you to see what's going on. So here we go. We have y equals x minus 5. Right here, this is our x. The number on the outside is this negative 5. That is our y-intercept. Okay, the number in front of x, there is no number, but there is. There is a 1, and we're going to make that a fraction. 1 over 1, this is the slope. You always graph the y-intercept first. So negative 5. 1, 2, 3, 4, 5. That's my point right there. That is my y-intercept right there. From the y-intercept, I graph the slope, which is the rise over the run. It's the y over the x. I'm going to go up 1 over 1 from this point. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. A lot of up 1s and over 1s. And I could do the opposite, go down 1, go over 1 the opposite way. And there you go. This is my line. Okay, so this is the line of this equation. All right, and here we go. Here's the x. This is the number that's right next to it, so that is the slope. This is the y-intercept. So the y-intercept is negative 8. So here we go. 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. That is right here. From this point, we're going to graph the slope. We got to make that a fraction. So it's going to be up 2 over 1, the rise over the run. So we go here, up 2, 1, 2 over 1. We do it again, up 2, 1, 2 over 1. We do it again, up 2, 1, 2 over 1. And then, so there we go. There's our point of intersection right there. Up 2 over 1, 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 up 2 over 1. Opposite, down 2 over 1 the other way. And we can connect all these dots. And we see that this is our solution. This is the point of intersection. This point is on the purple line, and this point is also on the blue line. And this is the equation right here of this line right there. Okay, so what is our solution? Our solution is 1, 2, 3, negative 2, which is exactly what we came up with, 3, negative 2. And so this is solving the equation algebraically, which is what you're going to have to do. And then in chapter 8, what we're going to do is we're going to solve these equations graphically. So you can actually solve these 2 different ways, and they're totally connected to each other. Okay, so let's see how you did on the next example. Check it out, example 1b, right here. Okay, so again, this is equal to y. Y equals 3x minus 7, and then y equals 6 plus 3x. And those 2 equations are both equal to y. So since they're both equal to y, we can set them both equal to each other. So we have 3x minus 7 equals 6 plus 3x. All right. We are going to get the x's on the same side, 3x and 3x, which is smaller. They're both the same, so I'm going to subtract them. And here we go again. They cancel out, and we're left with negative 7 equals 6. Is this a true statement or a false statement? It is a false statement, okay? So this means that there are no solutions. So whenever you have no solutions or infinite solutions, you don't really have to check it. That is the answer. So for your homework, you would be done. Let's go ahead and look at it and see again what's going on with the graph of this. So there's both of the equations right there. So let's graph the first one. This is the x. The 3 is next to the x, so that is the slope. This number on the outside is the y-intercept. We're going to start by graphing the y-intercept. So negative 7, we're going to go down 7. 1, 2, 3, 4, 5, 6, 7. There we go. From there, we're going to do the slope, and we always have to make this a fraction. This is the rise over the run. So from this point, we're going to go up 3, 1, 2, 3, and over 1. Up 3, 1, 2, 3, 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 over 1, and or we could start from here and go the opposite. Down 3, 1, 2, 3, over 1 the other way. And there we go. This is the equation of that line. This is the picture. This is what it looks like. Every single equation has a picture that corresponds with it. Okay, good. So we have that one done. Let's go on to the next one. This one's kind of out of order, but all we need to do is find the x and the number right next to it, and we know that that is the slope. Okay, and then this number on the outside is the y-intercept. So we're going to go up 6. 1, 2, 3, 4, 5, 6. And then we're going to do the slope, change that into a fraction, which means you're going to go up 3 and over 1. Rise over the run. Up 3, 1, 2, 3, over 1. I can't go any farther, so I'm going to do the opposite. I'm going to go down 3, 1, 2, through 1, 2, 3, over 1 the other way. Down 3, 1, 2, 3, over 1. 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 And then there we go. No solution means that what we have is we have, again, two parallel lines. And remember, with parallel lines, they always have the same slope. And maybe you caught that, I don't know. But if you look here, on the first equation, the slope is 3. And on the second equation, the slope is 3. So just by looking at the equations, we totally could tell just that they're parallel lines, which means there is no solution. There's no points that they have in common. There's no points of intersection. They never touch. They never meet. That's it. So if you got that one right, great job. Super proud of you. We will see you next time.